So over on page 589, we've got this new thing called tokenizing strings. And what's great about tokenizing strings is we can kind of take a string and we can kind of split things off of it depending on what's in there. It says tokenizing a string. Let me bring this up. It says tokenizing a string is a process of breaking a string down into components that are called tokens. The string tokenizer class and the string class split method can be used to tokenize strings. So, for example, if I've got a string that's got peach space, raspberry space, strawberry space, vanilla, we can split that by this thing called a delimiter. And a delimiter is basically a way to split things out. So I could split this out by spaces, and it would split it into 4 separate items. Down here I've got numerics 17 to 92, 81, 12, 46, and 5. I could split that out by semicolon. Down here is a date. I could split that out by dash. Down here is /home /R Sullivan /data, and I could split that out by /. So the string tokenizer class, we automatically bring that in with the java.util string tokenizer. And just like the other ones, I could just go ahead and use the string tokenizer. The red squiggly line will allow me to click on it and automatically import it in. So here's some constructors from the string tokenizer. I can bring in a string into the tokenizer. I can bring a string and the delimiters as 2 separate parameters. I could have 3 separate parameters, the string itself, the delimiter, and then the Boolean return delimiters. And if that's set to true, the delimiters will also be included as the token. It defaults to false. We normally don't want to return the tokens, but we could do that. So here's what it looks like. String tokenizer space str tokenizer equals new string tokenizer, double quote 2 space 4 space 8 space 6 space 8. I could also do another one where it's 10-14-2013 and then comma, and notice it's got the dash as the tokenizer. Or down here is the same thing with true at the end, where we want to return the actual token itself, which would also be the dash. So that's how we create a token, a string tokenizer. How do we extract stuff off of it? Well, here's some methods that come with the string tokenizer. We've got count tokens, and it returns an int. Has more tokens, and it returns a Boolean. Next token, and it has a string. So if we look at this, I've got string tokenizer, str tokenizer equals new string tokenizer. So we instantiate this as a new string tokenizer. And I've got the word 1 space 2 space 3. Now we're going to put this in a while loop. While string tokenizer has more tokens. So there's that Boolean. So it's going to return a true or false. And we're going to print str tokenizer dot next token. So that's pretty cool. So what's nice about this is it basically, since I got 1 space 2 space 3, the space defaults as the token. So it looks at it and it says, is this true? Are there more tokens? Yeah, there's a number 1 right there. I go ahead and print that out, and it's going to print the number 1. The space automatically is a token, so the word 2 becomes the next token. So when it comes in here and says has more tokens, yep, the number 2 or the word 2 is there, and it prints that out when it string print next token. There it is, prints the 2. And then it has more tokens. 3, it's now pointing at the third one. That's true, so it comes in and it prints the next token, so it's going to print the word 3. When it comes back to this while statement, it says has more tokens. Well, it's now sitting there at the end. It basically, there are no more tokens, so that basically while statement becomes false, and it drops out of that whole loop. So let's take a look at the date component. And so notice it automatically brings in our java.util string tokenizer. Here's our class date component. We've got 3 instance variables, string month, string day, and string year. So down here is my constructor, and we're bringing in a string, and it's a date str is the name of the variable. We create a string tokenizer called str tokenizer, and it's instantiated as a new string tokenizer, and we're going to bring in that date string, and the / is going to become our token. I'm going to say month equals tokenizer next token. Now look at this. I didn't put this in a loop. It just grabs the next token, which happens to be the first item, which is month. And once it gets done with that, it's now sitting at the next token. And so it says day.string tokenizer next token. It automatically grabs that next token. It's now sitting at the last token, which basically is year equals to the next token, and it puts it in. So the next token automatically grabs the next token that's available, because it basically this slash right here is the token, and it'll grab the next grouping of items. Then we got get month, get day, and get year, and it's going to return each one of those. So what is the I think it's called this. Yeah, it's this. Is it the split demo? No. Wow. Well, which one is it? It's the date component. Date tester. That must be it. Yep, there it is. Date tester. So public static void main. We got string day equals 10/23/2013. We go ahead and create a new date component. It's called DC. We're going to instantiate it as a new date component. We're going to pass the date. Then it says here's the date, and it's going to display the date. And it says the month is dc.getMonth. The day is dc.getDay. And the year is dc.getYear. So pretty simple. We click on the run. Here's the date, 10/23/2013. The month is 10. The day is 23. The year is 2013. Before we go on, let's take a look at the split demo. And so another way we can utilize just splitting something out is, now this is different from tokenizing. This is the split method. So string str equals 1 space 2 space 3 space 4 3 space 4. And then I say string. Now notice we're making this into an array. We're going to call this tokens. It's going to be equal to str.split, and it says split on the space. And now I'm going to use an enhanced for loop, and it says string s. So it's going to grab each token one at a time, throw it into s, and we're going to print that out. And then string str2 is equal to 1 and 2 and 3 and 4. So it's got space 1 and, so now I create another array. It's a string array. It's called tokens2, and that's equal to str.split space and space. So from here to here is the token. We're going to do the same thing. We're going to go through the for loop, the enhanced for loop. We're going to grab each token one at a time, or each element out of this array one at a time, throw it into S. We'll print S. Now look at this one. I've got string str equals joe@gaddisbooks.com. I create another string array. It's going to be called tokens3, and it's equal to str3.split. Now look at this. I'm going to tell it to split on multiple tokens. To do that, I have to put square brackets around the tokens. So the @ symbol is a token, and the period is also a token. I do the same thing. It's an enhanced for loop. It's going to grab each token, put it into S, and it's going to print the S. So when we run it, there is so our first one is 1, 2, 3, 4. So there's our 1, 2, 3, 4. The next one is 1 and 2 and 3 and 4. And the space and space is the token. Same thing there. We got 1, 2, 3, 4. Down here is joe@gaddisbooks.com. And the tokens are the @ symbol and the period. Look at that, Joe, Gaddis Books, and com. So a couple different ways to split things out. We can create a string tokenizer, or we can use the string.split method. If we take a look at split demo 2, yeah, and 3, yeah, that's so yeah. My split demo 1 did it all in one fell swoop. If we take a look at split demo 4. Look at that. I got Jill, $, Billy, %, Becky, asterisk, Tara, ampersand, Mary. So now I basically do string. I'm creating a string array called tokens again, and it's equal to str.split. And notice the square brackets around the $, asterisk, and. So each one of those is going to be the token, and it's going to split on each one of those. And again, I'm going to take each one of those tokens, put it into S for this enhanced for loop, and it's going to print each S one at a time. So when it's ran, there is Jill, Billy, Becky, Tara, and Mary. Over on page 591, I want to spend a whole lot of time on this, but when we utilize these types of things like this, there is a thing called regular expressions. And what regular expressions are is we can bring in a specific textual string, and then I can have it split things out just like we saw here on certain items. If you ever look at if you did a search on regular expressions and looked into it, it really is a super it's I have it up here in my mind. I understand what's going on, but for me to utilize it, I really have to have a book sitting right here, and I have to go through it because it's very powerful, but it's not easy to read. But just realize that we could spend an entire semester on regular expressions. It's a it's almost like a programming language by itself. But yeah, I've utilized it in the past. But like I said, for me to use it, I literally have to have a book so I have something to reference because it's got so many complex parts and pieces to it. Okay. So any questions so far? Okay. Now it's a good idea to use trim before you tokenize. So let's say right here I've got space 1, semicolon 2, semicolon 3, and space. So if I were to print these, it would print out space 1, and then 2 has no spaces, and then the 3. So the best thing to do would be to so take the same exact code up here, except down here what we're going to do is right here I'm going to do new string tokenizer string.trim. So it's going to trim off any leading and trailing spaces, so that when we run this code, it's just going to have 1, 2, and 3. So that's probably good practice whenever you're tokenizing or splitting, is to use the trim method to make sure there's no leading and trailing spaces, so it doesn't look like this. Instead, it looks like this. And we've already covered the split. Okay, so on page 594, we have wrapper classes for the numeric data types. So we've been using the byte, double, float, integer, long. We've been using these so far, but and they do have a toString method built into them. So let's say I create an integer I and it's set to 12. I've got a double D and it's set to 14.95. I can create a string str1 and make it equal to integer.toString I, and that will convert 12 into a string and put it into this string variable. The double.toString D will take this 14.95, convert it to a string, and put it into str2. We also have these, do I have an example of those? Let me see. Yeah, I'll see it here in just a sec. What's really cool is we also have inside of these integers, we do have one called toBinary string number, toHex string number, and toOctal. Now binary, if you know what binary is, that's basically a numbering system that's just got a 0 and a 1. And the numbering system goes 0, 1, 10, 11, 100, 101, 110, 111, and then 1,000. That's the numbering system for binary. Hexadecimal is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. Okay, and if you really got into like the caching system and that type of thing, we really got into it a lot in COBOL and oh gosh, what's the other language? It's an antiquated language. Assembler. Assembler is a really antiquated language, but we really had to get into the binary of the addresses on that. So hexadecimal, we lived in hexadecimal. Octal is 0, 1, 2, 3, 4, 5, 6, 7. There's 8 numbers and that's it. So octal is half of hex, with hex is 16. Octal is, so we would sometimes get into that as well. Well, this will automatically convert regular digital numbers, decimal numbers, into binary, hex, and octal. And we're going to see an example of that here in just a sec. The next thing we have is the min value and the max value. So what's great about this is utilizing a byte, double, float, int, long, and short, we can find out what the minimum value is for that data type and what the minimum value is for that data type. And so here I can say the minimum value for an int is integer.minValue, and it will give us the lowest value that's allowed for an integer, or max value again. I don't know how often we would need to use that. Maybe if we're doing some type of error checking to say if we basically get some type of error where it's out of bounds, we might use this to basically just explain to the user this is why we got the out of bounds exception. That's kind of one of the only reasons I can see using that. Again, we're going to see example for all these here in just a sec. I just want to talk about them first. So the next thing we have is this auto boxing and unboxing. It says it is possible to create objects from a wrapper class. One way is to pass an initial value to the constructor shown here. Integer number is instantiated as a new integer 7. This creates an object that has a number 7 in it. So if we look at integer number and then number equals 7, that does the same exact thing as we saw up here. So this creates an empty shell of an integer class called number. It's an object called number. And when I say number equals 7, it basically instantiates it and adds 7 to the value. So auto-boxing is Java's process of automatically boxing up a value inside of an object. And that's basically what we did right here. When I said number equals 7, it automatically boxed that number 7 into the integer object number and basically put that value in there. Now, unboxing is just the opposite. It's the process of converting a wrapper class to a primitive data type. So if I've got integer myInt equals 5, that auto boxes the value 5 into the integer class object myInt. If I create an int primitive number, I can say primitive number is equal to myInt, and it automatically unboxes the integer object myInt and puts the value of that into primitive number. So let's take a look at the static toString inside of our static toString. There we go. So let's take a look at this. So I've got int I equals 12 and double D equals 14.95. I'm going to create a string str1. I'm going to make it equal to integer.toString I. So again, it's going to convert that 12 to a string and put it str1. And double.toString D, it's going to take that and convert it to a string and put it into str2. And when I print str1 plus dash str2, we're going to see that they're both going to be left aligned because that's what strings do. If I take the number 14, I'm going to convert it to a binary. I'm going to convert it to a hex. I'm going to convert it to an octal. And here's the minimum max. I can say the minimum value for an int is integer min value, and the maximum value for an int is integer max value. Auto boxing, so I'm going to create an integer.num1 equals new integer 7. Now, whenever you see something like this in the Java world, you see something that's got a strikeout through it, here's what that means. That means that this is no longer used in Java, but we can still use it for now. It's called delegation. It's basically saying, hey, you can use this, but sometime down the road it's going to be removed. You won't be able to use it anymore. So we create an integer class object called num1. We instantiate it as a new integer 7. And then I can say integer num2 equals 7. That does the auto boxing. An integer num3, and then num3 equals 8. So all of those basically do auto boxing. Automatically take a primitive and throw it into a wrapper class, in this case the integer wrapper class. And then I can print num1 plus dash num2 plus dash num3. Auto boxing just the same. I can say integer myInt equals 5. It auto boxes the 5 into the integer wrapper class myInt. And then I can say int primitive number equals myInt. It unboxes the object into the primitive number, and then I can go ahead and print that out. I can also do, and I think that's on the next page, so an array list. Have we covered array lists? I think we have. An array list, and we use the less than and greater than symbols to say that the array list is going to be an integer data type. The name of this array list is list. It's going to instantiate it as a new array list integer, so it's an empty array list right now. And I can say integer myInt2 equals 5. That auto boxes it, and then I can say list.add myInt. So when we run this, so again, there's our string 12 and string 1495. There is the binary version of the number 14. There is the hexadecimal version of the number 14. And there is the octal version of the number 14. And then a minimum value for the int is negative, what is that? 21,474,000, no, That's 21,472,836 or two. Anyways, you understand. And then it's the maximum value is that. And then there is the auto boxing and boxing of those numbers, 7, 7, 8, and there's the 5. Any questions on any of those? Again, I don't see much use of the 2 binary and the 2 hex and the 2 octal. Auto boxing and unboxing are very handy in order just to grab a number from that wrapper class or give a number to that wrapper class. We don't have to go through the whole instantiation and that type of thing. We can utilize it that way. On page 597, let me get there in the book. It says, so we want to focus on solving the test score reader class. So Professor Harrison keeps your students' test scores in a Microsoft Excel spreadsheet. Figure 9-8 shows a set of 5 test score for 5 students. Each column holds a test score, and each row represents a scores for 1 student. So each row, so this row of 1, 2, 3, 4, 5 scores, row 1 is 1 student, row 2 is the next student, row 3 is the next student, and so on. In addition to manipulating the scores in Excel, Dr. Harrison wants to write a Java application that accesses them. Excel, like many other commercial applications, has the ability to export data to a text file. When the data in a spreadsheet is exported, each row is written to a line, and the values in cells are separated by commas. So here's what it would look like if we exported this Excel spreadsheet to what's called a comma-separated file, or a CSV. So that's what it would look like. We're going to actually download this here in a second. So let's do this. If we go to Google Classroom, let me know when you're there. And let's go to classwork, and let's go to Class Lab Extra Files, and we're going to click on Class Lab Files, and up here we're going to click on Open With, and let's do Zip Extractor. And what we want, what is the file that we want? Grades.csv. Do we see that anywhere in here? Grades.cs. There it is, right here. So we're going to do a, can I just do a right? Yeah, do a right click on grades.csv and click download. And that should be in our download folder. So if I go to our download folder, there is grades.csv. So here's what we want to do. I'm going to do a right click on that. And first of all, you got to know where do you know where your workspace is? If you don't know where your workspace is, you can click over here in Eclipse and click on File, Switch Workspace, and Other, and you can see the path to your workspace. So kind of know what that is. You can actually do a right click and copy it. And then back over here, after I do a right click on that grade CSV and click cut, up here in this downloads I can do a paste. Well, anyway, I can't do that, sorry. I happen to know where my workspace is. Here's my workspace. And there I see Chapter 9 Lab. I'm going to double click on that, and I'm just going to do a paste. Paste it right in there. Did you get it? You got it? Okay. So now I'm going to go back here to Workspace, and I'm going to open up the test score reader. And so this is a regular class file. It's got instance variables, and notice we got a java.io asterisk, so it's bringing in the whole everything that's inside the java.io. So we come in here, we got two instance variables. We've got a scanner input file and a string line. Here's my constructor, test score reader. We're going to bring in a string file name, and since we're reading the file, we always have to have the throws IO exception. So in there, it's got file, lowercase f file is instantiates a new file, and the file name. The input file is equal, so we take this file and we can create a scanner object called input file. So now we've got our file open, ready to go. We got read lex9, throws IO exception, Boolean line read, so that's going to basically, it's a true or false. I'm going to say line read equals input file dot has next. If line read, line equals input file read next line. So we're going to read the next line, and we're going to return that line. So read the next line is going to see if a line exists. If it does, it's going to read it and then return it. And what's nice is this class will keep track of where it's at reading those. So if it read line 1, the pointer is now sitting at the end of line 1, and it can see what's in line 2. We have get average. We create a local variable called total. It's an integer. It's equal to 0. We create a local variable double average, and we create an array of string tokens, line split, comma. Ah, that's cool. So we're going to pass in, we're going to look at our line. What's our line? That's our instance variable up here, string line. Remember, line up here gets set to whatever that next line is. It splits all those out by the comma, that's the token, and it puts it into this tokens array. Then I'm going to go through that array one element at a time and put it into string. I'm going to say total plus equal, because remember, these are strings. I can't do any addition on strings, so I got to convert them to an integer. So I say total plus equal integer dot parse int string. So this converts it to an integer and adds it to total. Average, on the other hand, is double. So look at that. We're casting the total into a double divided by tokens.length. So the tokens.length, we never covered that, but guess what? The tokens has it's just like a regular, no, we have covered this. I'm sorry, we have. We do know the length of an array. I was thinking of tokenizing. No. So this tokens is an array, and we can do a dot length, and it will tell us how many elements are in that array. I divide by total, convert it to a double, and throw it into average. Then I return average. And then I've got void close, throws an IO exception, and this is where we close the input file. So that's the class. So how do we utilize it? Well, I think it's test score averages. Yeah, test averages. That's our public static void main. We create a double called average. We create an int student, and we set the initial value to 1. Here's where I create my test score reader. The object's going to be called score reader, and we pass in this grades.csv. So back over here, when it does in the constructor, it's going to open that file because we pass that file, and that file better be local to wherever this is, and it will be because we've got it pasted in there. So when it gets through with that, we've got the file opened. And then I can say while score reader dot read next line. So while that's true, we're going to say average equals score reader dot get average. Remember, it's going to take it and tokenize that string, get the total, divide the total by the number of elements in there, and it's going to put that in average. Then I can say the average for student number is average, and then I'm going to add 1 to student number. It's going to come back up here, and while we can read the next line, it's going to keep doing that. And then when we say, and at the very end, we're going to say score reader dot close, and then we're going to print no more scores. So we go ahead and run this, and cannot find the file specified. You know what? I just remembered. We got to put that farther in. We got to do this. I'm going to do a right click on grades and do a cut. I'll open up SRC, and I'm going to double click on lab 9. No, I don't need to put it there. I'm sorry. I'm just going to put it here, paste it here. Yeah. So it's got to just be outside the lab 9. Now let's run it up here. Let's see what it looks like. But maybe I put it too deep. I think I put it too deep. So let's do a right click or click on grades. Let's do a cut. Let's go back to workspace. Yeah, just put it right here in chapter 9. Yeah. Lab, no, like chapter 9 lab. That's where I should have put it. My bad. Let's put it there. Did yours run okay? Yeah. So now let's run it. Damn it. Does it have to be here? Right here. It's not going to work there either. Oh, that's right. I'm thinking we're in chapter. My bad. I thought we were in the lab. My bad. Yeah. I knew it was at the top level. Now let's run it. There we go. So again, it read that first line, got the average, student 2, the average, student 3, 4, 5, and then no more scores. So any questions on that? Okay. Do you want to do a lab or you want to call it a night? Okay, let's do that. Okay, so over here, I believe it was, I think it's, which one was the,